All right, we're going to do another example in finding the hypotenuse, except for this time, we're going to put it with a real life problem here. Okay, um, we're going to track Jim's trip from his house to school. He lives quite a ways away from school. It takes him a long time to get there. His normal route is up this street, which takes 16 minutes. Okay. And then he has to go over on this street, which is 12 minutes, for a 28-minute trip altogether to school. That takes a long time to get there, to walk. Think about having to walk 28 minutes if it's freezing cold outside. Now, he has a choice or an option of cutting across some different yards and lots to get to the school this way. He can cut across these lots to make his trip a little shorter, because it would definitely be shorter going directly from here to here than it would be from going all the way north and all the way east. Okay, so I want to figure out how far his trip would be if he cut straight across. If you look at what our map looks like here, we've got a right triangle. Okay, his trip looks like a right triangle. Here's the right angle, line drawn to the hypotenuse. So that's what we're looking for, is the hypotenuse here, to see how much time he saves on his trip. So that's going to be our C. Okay? The other two can be A and B. So let's use our Pythagorean theorem to figure this out. So we need to do 16 to the second power plus 12 to the second power, which is going to get us our C to the second power. So let's try this. 16 times 16. I'm just going to use a calculator to make it go a little faster. 16 times 16 is 256. We're going to add that to 12 to the second power. We've already had that in another problem. 12 times 12 is 144. If I add those together, remember I'm taking the square root of whatever I got, adding those together is going to get me 400. So now I just need to figure out what the heck is the square root of 400. Okay? I'm sure a lot of you guys can probably figure this out, but if you can't, try some things here. You know it's got to be bigger than 16, because 16 times 16 is only 256. So we need to go higher than that. Okay? 17 times 17 is 289. So we need to go higher than that. So I'm going to bump up a few here. I'm going to do 21. 21 times 21, 441. Too big. Okay, so I'm going to put this down here. That 21 was 441. So let's go down to, how about 20? 20 times 20 is 400. So that's the one we want, because 400, yep, there we go. Square root of 400 is 20. So now, if he takes this shortcut across here, that is going to only be 20 minutes. So if the question in this case was not really the perimeter, but the question is how much time would Jim save by cutting across? Normally it takes him 28 minutes. On this trip, it's only taking him 20 minutes. So in essence, he is saving 8 minutes. And in a snowstorm or a blizzard, or a really hot day, having to walk that extra 8 minutes could be a killer. So if we save 8 minutes by cutting across, that's a good thing. So we did this exactly like we did all the other problems, except for we put it to a real life situation here. We still had A and B. We still did A squared plus B squared. Got 400. Still found the square root of that. And our answer was 20 minutes for here. And if the question was how much time did he save, started out at 28 minutes. Now his trip only takes 20 minutes. He saved 8 minutes. All right, next example we're going to have here is we've got this guy right here, and he's standing on top of this shed or building that's 12 feet high. Okay. There's going to be one of those ropes that goes diagonal down like this. That's like one of those zip lines that you grab onto and then you go down on the rope. Okay. The landing spot is 9 feet away from the building. You want to know how much rope are they going to need here to connect it from the top of the building to the landing site. Now, if you just had this question and you didn't really think about it, it may be hard to picture. But me drawing this out in some kind of a diagram should really help you understand that this is a right triangle. Okay, so we can utilize our Pythagorean theorem. So my question is, how long a rope do I need? Is basically what we're talking about here. Okay, the rope is going to represent the hypotenuse, because the hypotenuse is across from the right angle that the building and the ground make a right angle. So let's see what the rope's going to be using the Pythagorean theorem. Remember, either the side of the building or the ground can be A or B. It doesn't matter because they're not the hypotenuse. So let's use 12 as A. So we'll do 12 to the second power. B is going to be the other one, so that'd be 9 to the second power equals C to the second power. So eventually we're going to be doing the square root. 12 to the second power is 144. 9 to the second power, what is 9 to the second power? 81. Yep, 9 times 9 is 81. Add those together, 144 plus 81, 225. Okay, now to find that length of the rope, we just need to know what the square root of 225 is. Okay, we know that 12 times 12 is 144. So it has to be bigger than 12. So let's try some things. Maybe I'll just try 16 to see what happens. Okay, 16 would be, if I did 16 times 16, that is 256. So that's too high. So let's try one less. Let's try 15. 15 times 15, 225. So that's the one we want. Okay. So we know that the square root of 225 is 15, because 15 times 15 is 225. So if the question is, how long does the rope need to be to make this happen here? The rope needs to be 15 feet long.